Okay, let's start with question 1. For DE 26.1, DE1, actually it's not a difficult question. You should have done it, but let's check answers for now. Right? Okay, we are supposed to find the general solution of this. So we will, how do we integrate? You look at the right hand side, it's a function of x, so we can leave it like that and we integrate one time with respect to x. But it doesn't look like something that it can be integrated directly. What we can do is to make it, either we use long division, or we do something like that, and we do a shortcut, and then we express this in this way. Alright? If we express like that, then it looks like something that we can integrate. 1 we can easily integrate, 1 over x squared, 1 plus x squared we can easily integrate. Is that alright? So this is the easy part. Integrate 1 you get x, integrate 1 over 1 plus x squared we get arctangent x. This is the easy part. Let's not forget our integrating constant plus c. Any questions so far? No? No, then we will carry on, yeah? So, but now the question clearly asks for the equation of the solution curve which passes through the origin. Right? Which passes through the origin. What do we do? The idea here is to find the integrating constant c. We then have to passes through the origin, which means when x is 0, y is 0. Now we have to go through this step. We cannot safely assume that c is 0 now. We have to go through this step of substituting 0, 0 into the equation. Alright, we have to go through this step of substituting 0, 0. Of course, it so happens that c is 0. Alright, it so happens that c is 0, and therefore the equation of the solution curve is given by this. I won't waste too much time on question 1, it's not too difficult, but I will pause for a while just to see if there are any questions at this point. If you're okay, just quickly type okay. Thank you. Thank you very much. Okay, let's jump to question 2 now. Now, this is solving a DE, but we are using substitution. Alright, we are given this substitution, which actually the technique is similar to what we see in the class test actually. Alright, we want the ultimate DE has z, but no y. So the easiest thing to do is really, if we are given this, we we differentiate both sides with respect to x. Alright, we differentiate both sides with respect to x. So dz dx equals differentiate 2x, of course you get 2, differentiate y, you get dy dx. Now with this thing, right, we can easily substitute back into the original DE, and we should be able to get it, this result, this dz dx result. Let's try. We make dy dx the subject. Alright, just minus 2 on both sides, and then we substitute the z equals to 2x plus y into the original DE, And I think the answer is not difficult, it's quite easily done. It's just that you have to, from here, let's pause here for a while. From here, it doesn't look obvious that we will get to this one, but never mind, let's persevere on. Let's persevere on. If you can combine them into a single fraction like this, alright, finally, alright, persevere on, we get this final fraction, and then we should be able to get it shown like that. Okay, if you're okay, just quickly type okay. If you need me to slow down, just type in and ask questions if you have. Thank you. Thank you. Okay, now we are supposed to solve this equation. But just take note now that this DE is of the type 2, the second type, where your right hand side here is a function of z, not a function of x. So we must be very careful. Before we start to integrate, we must do something to the equation such that the function of z appears on the left hand side, not on the right hand side. So just be sure, because only then you can integrate both sides. Don't make the mistake of integrating from this form, from the original form. Alright, we have to do this step here. Alright, so once we do that, then it's not difficult. Then we just integrate both sides with respect to x, and it's not that bad. Alright, it's not that bad to integrate both sides with respect to x, and the rest is easy, pretty standard. Some of us may wonder, may pause for a while. Never mind, can pause to think for a while how to integrate the left hand side. But if you look at it, it is actually this kind of integration. When you break the fraction up, and you should be able to see that you can integrate 1/3, you can integrate 1/3x, z, sorry. Let's not forget the mod sign. Let us pay special attention here. Is ln mod z. Yeah, ln mod z, not z, but mod z. Okay? And also, let us not forget the integrating constant c. Now, do we add two integrating constants, one on each side? Answer is not really necessary. You just need to add one constant on one side. We could have added it on the left hand side or the right hand side. It doesn't really matter. Okay. Seems like we have solved it, haven't we? Is this solution complete? Why not? Thank you very much, Xiaorin Xiaojing. Thank you. Yep, very good. It is the substitution is just to help you solve the DE. The original DE is this one. Wow, the highlighter not very nice. But never mind, you know what I mean. The original DE was y and x. So ultimately you should substitute back z equals to 2x plus y, and you should substitute this back. Okay, just as long as you see z, you will substitute it. From this step onwards is just simplification. I won't spend too much time. Just multiply both sides by 3. Alright. And then you get something like that. Just to make it a bit nicer. No problems. The only issue here is we have a 3c here, right? We have a 3c here. You may want to replace the 3c with a d. Doesn't really matter. After all, it's just a constant. Any questions? If you're okay, just type okay. If you have questions, then just type the question in. Thank you. Good. Okay, let's go on to 26.2. This is the part that many of you actually told me that this 26.2 is the most difficult of the three parts to DE, which is actually to formulate the DE given a scenario. Essentially, it's all about interpreting the question and changing the sentences into a mathematical expression. So look at the highlighted words there, the rate of increase of its temperature. So this is very important. I mean, some of you take physics, some of you don't take physics, it doesn't really matter. Rate of increase of its temperature. So very quickly, rate of increase of temperature is actually d theta dt. Right? It's proportional to the temperature difference, and in this question it's easy. They give you temperature difference as 20 minus theta. So all of us will then be able to write this. Just write this down first. Don't be too ambitious. Just write this down, which is given. Shouldn't be that bad. All right. Of course, we know proportional sign we can easily change to a constant. Change that with a constant k, and we are done. Of course, I mean, once we get this, then the rest is quite easy. But first, there are a few things that we need to look after. There's this k that we don't know. Later on, we have to solve. And there are a few things like this 10 degrees and this one we have not used so far, so we have to use it somehow. But never mind. It is now given that the rate of increase of the temperature initially, we must also understand this word initially. Initially actually just means at T equals to 0. Okay, at T equals 0. So we must first interpret that. Now we are given that when T is 0, theta is 10, and d theta dt is 1. So we must learn how to draw these information out of the question. So if we can see that, then quite easily we can get K. All okay. Yeah, quite easily we can get K. So we got K out of the way. Now we can focus on solving the DE. Again, to solve the DE, look at the expression on the right. It has theta, so we are not going to integrate it in this form. We are going to divide both sides by 20 minus theta so that we can easily integrate. This is of the type 2. It's of type 2, so we have to shift the theta on the left hand side. So of course the integrating I'm not going to go through very much. Just don't forget to put two things. Theta, the ln mod, don't forget the mod, and don't forget the negative sign. This negative sign here. And don't forget the mod sign. Okay? Okay? So, then we rearrange a little. Now at this point, you must be quite comfortable with removing the mod sign. Okay, I've gone through before how to remove the mod sign. Alright, so I will not repeat it here. So to remove the mod sign is just like that, where A is any constant. All okay. Do you all need me to go through how to remove the mod sign here? Yes? No need, huh? Anyone has any burning questions? No, okay. I don't hear anyone. Where did the negative come from? Okay, anyone would like to answer? Yeah. Because of this negative theta here. Yep. Be careful, yeah? Any other questions? From second last line to last line, all okay? Oops. Okay, Jia wants me to explain how do we take away the mod. Okay, fine. Let me just use another whiteboard here. Equals to negative. What is that? What is it again? Let me see. T over 10. Okay, now what we are saying is this, therefore 20 minus c minus theta mod is equals to e to the power of negative c e to the power negative 10 over 10. I'm writing very slowly because the stylus on this whiteboard doesn't work very well. Now, let's recall what do we mean by mod sign. So, can we safely say that 20 minus theta, okay, is either equals to the positive, okay, let this be b, yeah, because e to the power negative c is just a constant, positive constant in fact. So it can either be b e negative t over 10 or negative b e to the power negative t over 10. Alright, quite obvious because if you take mod, the expression in the mod can either be a positive or a negative, because ultimately after you take mod, you will get the positive sign. So can we then finally write 20 minus theta equals to a e negative t over 10, where this a can either be a positive or a negative number, that where a is just another constant. Okay? Good. No problem. Okay, just a refresher. I know Jia Jin is the only one who asked the question, but I thought some of you may be not 100% clear, so I thought I better go through this piece. Okay, let's move on. Once we get that, then we make theta the subject of the formula. Okay, when theta the subject of the formula, we can move on. Now, notice we have another constant a here. Obviously, of course, we solve a d, we must have another constant. Now, but in your final answer, there is no constant. There is a 10 over there. There is a 10 here. This is what I need. There's a 10 here. So we have to show that a is 10 somehow. We have not used something. We have not used the fact that at t equals to 0, theta is 10. Because initially, theta is 10. So if we make use of that, then quite easily we can get, we substitute this, oops, sorry, at t equals to 0, theta is 10, we can solve a is 10, and hence we have shown this expression. If you are okay, just type okay. If you have any questions, just type your questions down in the chat box. Justin's question, is it okay to solve the d with k first and then solve for k later? Yes, I suppose it's okay. When you solve for k, you are still substituting back into the dE to find k, am I right? Am I right, Justin? Are you going to substitute back into the dE? Yes, you can. Because the only way to solve for k is to substitute back into the dE. Yeah. The rest okay? Good? If good, then we will move on to 26.3. Oh no, sorry. No, not yet. Sorry. There's still second part. So sorry. Okay, second part. Find the time the liquid takes to reach a temperature of 15 and state what happens to theta for large values of t. I think the first part, how to find the time taken, is actually quite easy, just substitution. I don't intend to go through, I just intend to check answer 6.93 minutes, 10 ln 2, or 6.93. I'm not intending to go through this. Can? Now, let's go look back at the dE again. And we are supposed to state what happens to theta for large values of t. Now, if t becomes very, very big, then it's quite obvious to us that then the term here, at the back here, this one, becomes 0. Alright, you imagine you substitute t equals to 10,000, 100,000, that term becomes close to 0, and we will say that. Just for presentation, we make it very clear, it tends to 0 for that term, the second term there. Therefore, for large values of theta, theta approaches 20 degrees. Then we try and sketch theta against t. Now, if you look at the GC, this is what you see from the GC, I believe. Alright, don't copy it. I mean, I don't think you will copy this. You should have done it. But this is what you see from the GC. I'm just trying to explain that you should interpret the sketch from your GC and then transfer it onto your own sketch. There is a reason why they ask you what happens to theta for large values of t. It actually means that theta equals to 20 degrees is a horizontal asymptote. So while you can transfer it, you must make sure that theta equals to 20 is a horizontal asymptote. And you must also then be very clear that at t equals to 0, theta is 10, which is given in the question. Any questions? Or okay, if you're okay, just type okay. If not, if you have questions, then you just type a question there. Okay, good. Oh, sorry. Ivan asks, must you show the graph at negative t? Anyone would like to answer that question? Okay, thank you very much. Okay, let's move on. Day 6.3. This is about sketching family of curves. Okay. Before I start on this question, let me just emphasize that generally when they ask you to sketch a few types, a few typical members, we will sketch A less than 0, A 0, and A positive. In your graph, we never label A equals to negative 2, A equals to 0, A equals to 2. We will always label A negative, A 0, A positive. Reason is very simple. What we want to do is to sketch the family of curves. We're not interested in the specific intercepts or turning points or whatever. What we are interested in are the common characteristics. Common characteristics of all the family of solution curves, of the entire family. Alright, so there are three things that we need to look out for. One is the common asymptote, if any. Okay? Two is the locus of stationary point, if any. And lastly, are there any common points, if any? So all three, I put down that if any because it may not exist for some DE. Right? Every one of them. Right? So you really have to check. Okay? Usually 1 and 2 are more common, 3 is less common. But we still, if you can understand, later I'll use question 1 and 2 as an example, the two questions as an example, but if you understand the principle, it's not that difficult to check. Alright? So, let's look at question 1 now. If we go through the process of checking 1, 2, 3, this is how we will do it. This is how I would do it. Now, how do we check common asymptote? Common asymptote is definitely found from the general solution. You are essentially asking yourself, as x tends to positive infinity or negative infinity, will y tend to a common straight line regardless of the value of a? Okay, I say again, will y, as x tends to infinity, positive infinity or negative infinity, will y tend to a common straight line regardless of the value of a? In this case, yes, because if you look at it, as x tends to infinity, not negative infinity, it's just infinity alone, that last term tends to 0. And therefore, y tends to x minus 1. I don't care what is the value of a, this will be the tendency, this will be how y behaves as x tends to infinity. So, like I said, regardless the value of a, therefore, y equals to x minus 1 is a common asymptote. Right? So I repeat, the common asymptote is definitely gotten from the general solution, not the DE. However, for number 2, the locus of stationary points, we have to read from the DE. If the DE says this, of course for stationary points you substitute dy dx equals to 0, and you get this expression. All we are saying is, for any point where dy dx is equal to 0, the x coordinate and the y coordinate are related with this expression, with this equation. So which means, therefore, then all stationary points must pass through y equals x. Is that all right? Now, the third point is a common point. Remember, common point. Now, the question you are going to ask yourself is, are there any values of x, x, where you substitute into the general solution such that y takes the same value regardless the value of a? Let's go back and look at the general solution. I'm looking at this general solution. Are there any special values of x such that you sub in, alright, and you get the same y coordinate regardless the value of a? In this question, we look at this. No matter what x you substitute in, the y is different for different values of a. So answer for this question is no. Do you follow what I'm saying? Are you okay? If you're okay, just type okay for the 3 points. 1, 2, 3 for this question. Are you okay? If you're okay, just type okay. Okay, I saw Chloe not being very okay for 3. Would you like to elaborate a bit more, Chloe? Why can't we just make a disappear since the value? The problem is we can't, for this equation, we cannot make a disappear. A will never disappear. For whatever value of x you substitute in, a can never disappear. Maybe I give you a counter, maybe I give you an example. Alright, maybe I use another piece of. If you have a y equals to x squared plus a x. Okay, just very or plus 4. Okay. If this is a general solution, you will have a lot of points, right? A lot of curves. You have a negative, a 0, a positive. Now, no matter now there is a common point. No matter what is the value of a, when x equals to 0, y must be equals to 4. Now this is always true regardless of A. So therefore 0, 4 is a common point. Can? For this case. Chloe? Good, thank you. So let's go back to the question again. So now we checked 1 and 2. 3, there are no common points. Now we can go ahead and sketch the curve. Now from your GC, this is what you see. I'm sure every one of you got this sketch from the GC. Now again, we must be discerning. We must have done our analysis before getting this screenshot from the GC. Right? We must have done our analysis before we get this screenshot from the GC. So, okay, sorry, I'll just pause a while. I get my power adapter. The laptop is running low on battery. Just give me 1 minute. Okay, sorry. So this is what you get from your GC. But we must know that y equals x minus 1 is a common asymptote. Whoa. Oh, sorry. Can you hear now? Okay, sorry. There was some internet connection problem. Okay, let's carry on. Sorry. So we must know that y equals to x minus 1 is a common asymptote. And we substitute. In fact, if you substitute a equals to 0 here, a equals to 0 here, y equals x minus 1 in fact is one of the solution curve. So I'm just going to show the answer here. This is the part that we need to be discerning. Alright, a few important points. The blue solid line is a solution curve where a equals to 0. It is also a common asymptote. It must be very clear in your sketch. Alright, then the y equals to x, the dotted black line, is where the stationary point must pass through. So you must make it obvious that then this minimum point, this minimum point, this minimum point, just trying to sketch, this minimum point must pass through the line y equals x. Alright, any questions here? Compare your sketch with the sketch that you see. Any problems? If you're okay, just type okay. If you need me to clarify something, yeah, just feel free to ask. Okay, not falling asleep already. Good. Okay, good. Okay, question 2. Show that the general solution is this. Actually, the first part is more of solving a DE. Now, and then we are supposed to integrate like that. Now, how do we integrate ln x? How do we integrate ln x? It's not so obvious. It's not very obvious. Yes, meaning you're right, because there's no standard form of integrating ln x, but if you know your techniques of integration well, yes, integration by parts. Integration by parts, because we know how to differentiate, we don't know how to integrate. So we will use IKID. Alright, we integrate 1, we differentiate ln x. So use IKID. Okay, at this point I should go a bit faster. This is not that bad, it's just techniques of integration. Again, your integrating constant A should just appear one time. Don't need to appear left hand side and right hand side. Then we get what we want. Sure. Okay, hand sketch 2 members, one for A positive, one for A negative. So we go through exercise. Are there any common asymptotes? Common asymptotes means you look at the equation, as x tends to infinity, does y tend to a common straight line? That you have to look at your general solution. Answer is yes or no. Any common asymptotes? Come on, be brave. Answers. Yeah, very good. No common asymptotes, because you look at the general solution here. As x tend to infinity, will y tend to a common straight line? Will y tend to a common straight, the important word is common straight line. No, it will not, because whatever it tends to, it will be dependent on A. So therefore, answer is no common asymptote. Ivan, okay? Good. Next, we check locus of stationary point. Is there a locus of stationary point? Usually 9 times out of 10 is always it will be there. And in this case, we just look at the dy dx, or rather the dE. We will get dy dx equals to 0. And then ln x equals to 0. But don't be contented with ln x equals to 0, because ln x equals to is not an equation of a line or a curve. Actually, ln x equals to 0 means x equals to 1. So x equals to 1 is therefore then the locus of stationary point, which is all stationary points must pass through the line x equals to 1. Lastly, we check common point. Common point. That means, are there any value of x such that y will take on the same value regardless of the value of a. Are there any common points? Come on, be brave. Okay, thank you. All of you are right, no common points. Chloe actually asked me to repeat the common asymptotes part again. Okay, can we all, Chloe especially, look at this part here that I wrote. As x tends to infinity, what does y tend to? Whatever it is, it doesn't tend to a common straight line. It doesn't tend to a common straight line that has no a. So there's no common asymptote. We contrast this with question 1, where there's a common asymptote. Look here. Sorry, let's go back here. Look here. As x tends to infinity, this whole term disappears. As x tends to infinity, this whole term disappears. So therefore, there is a common asymptote. Okay, thanks, Chloe. Okay, now let's go to the sketch now. This is what you see from NGC. Not bad. Quite informative. This is what you see from GC. So let's transfer it onto your graph. And you know that x equals to 1 is a locus of stationary point. Looks as if it's correct. So we just transfer it onto your GC for a is negative, a positive. The only thing that many of you will miss out is the hollow circle. Anybody would like to explain this hollow circle? Yes? No? Qianhua, very good. All understand? Qianhua's explanation should be quite clear. Very good, Yatong, very good. Alright, that's the end. We've gone through the 3 assignments quite efficiently, I hope. I think all of us are yawning. I don't think we want to carry on and do more questions, but I thank you for your participation. Thank you for your attendance. If there is an opportunity that we can have another such lesson, just to cut some time. Any questions, sorry, before we really end? No problem. Okay, if you are okay, then just close your window, go to sleep. Good night. Thank you. Thank you. Thank you. Bye.